Recording in progress.
Okay. Believe or not, we already finished 12 weeks. Okay. In the last 2 classes, I will go through everything you have learned so far. Okay. Let's do a quick review. This is part 1. Next class, as the last class, we will do another part of the review. Okay. Let's first do some domain and range questions. Okay. Let's see the first one. Y equals to square root of x minus 1. Okay, look at this. Let's see. Brian. Let's see here. How do you do the domain and the range? If you put, if you leave this under the square root, you want this guy to be positive or equals to 0, correct?
Yes.
So you do x minus 1 bigger than or equal than 0. It can be equal to 0, but it cannot be less than 0. So x is bigger than equal than 1. It's the domain. If you want to write down the set notation, this is called the set notation. If you want to write down the interval notation, you put the brackets 1 to infinity. Infinity is something you cannot equal, so you do an open parenthesis. All right, that's number 1. We'll do one more question. Number 2. First, Brian, I ask you, y equals to this. What's this?
Isn't it quadratic?
If you use y equals to 9 minus x squared, that's a quadratic. If you have a square root, it is not going to be a quadratic. Okay? Does that make sense? Look, when you do this guy square, and you do this guy square, how much is this after you do the square?
9 minus x squared.
And then y squared plus x squared equals to 9, correct? Yes?
Yes.
X squared plus y squared equals 9. Who is this? Is that a standard equation for a circle?
Yes.
What's the center? What's the radius? Center is 0, 0. Radius is 3. Does this make sense to you?
Yes.
So this guy, you can say, if I do the y squared equals this, and then x squared plus y squared equals 3 squared. So that's a beautiful circle. But here, y equals to positive. That means it's a semicircle. It's a top half, okay? It's not going to be the bottom one. It's going to be the top one. That's number 2. Does this make sense to you? Your school is learning this stuff right now, correct? Or similar? Aiden. Number 3. What's this?
The domain and range. It's negative infinity, positive infinity.
Hold on. The denominator could not equal 0, so it's not going to be negative infinity to positive infinity.
Right. Negative infinity to 0, and then u, and then 0, positive infinity. 0 is not inclusive. Open.
Exactly. So it is negative infinity to 0, union. This is called a union, okay, with 0 to infinity. Or you can say x is bigger than 0 or x is less than 0.
The teacher lets us write x is not equal to 0. And just,
Yeah, that's also fine. If they ask you to write an x not equal 0, you can also write down that way. Let me ask you this. What is the range for this one? What is the range?
it's like, it's a -1, and then like, hold on. So,
When x is bigger than 0, this is 1.
and when x is
When
less
x
than
is
0,
less than 0,
-1.
there you go. So you draw this. Make sense?
Makes sense.
Yeah. And you
Yeah.
have this, okay? This is something very important because next year when you learn calculus, we will learn about this. This is called a jump discontinuity, okay? This is jump discontinuity. Okay, yeah. So basically that's our first 3 questions. And then number 4. Number 4, we come to our old friend, which is sine, cosine, tangent, and cotangent, secant and cosecant, okay? All right, everybody please go ahead. We learned drawing way more complicated function graph than this before, okay? Can you please go ahead, draw on your paper for sine, cosine, and tangent, cotangent, secant, and cosecant, okay? All right, go ahead. Please draw on your paper. Let me call student, okay? Christina.
Yeah.
I'm going to make you to be the co-host, okay? And then I'm going to share my screen. Okay, I'm going to share my screen. And then can you request remote control, Christina? Yeah.
How do I do that?
Remote control. Okay, hold on. I'm going to give you remote control. There you go. Do you have my remote control? Did you see? Yes, there you go. Okay, go ahead. You can draw the sign. Okay. Let me change this to the line. Hold on. There you go. Yeah. You can draw on the screen. Go ahead. You can draw the sine function. What does sine looks like? Like that. Very good. Wow, you draw very beautiful. Very good. Would you please mark down position as 0, pi, and 2 pi? Very beautiful. That's about the sine. Now hold on, okay? Hold on, give me 1 second. Hey, don't move, please. Don't move. Now, Christina, you can go ahead. Draw the cosine x, please. It's not showing what's going on. Yeah, you can undo. You can click undo. It's in the annotation button. You can click the annotation.
Okay.
Yeah, in the annotation menu, you are able to click the undo or redo or erase button, okay?
I'm clicking undo, but it doesn't undo.
Let me try this, okay? All right, you can do it.
Are
you able to do it now? Try one more time. You should be able to draw it. You can use your finger to draw, okay? Or use your mouse. Yes. You want to modify it a little bit. Okay. Cosine start from the peak, right? Yes, there you go. Can you please mark 0, pi, and 2 pi? There is pi. Very good. And then the other guy is 2 pi. Nice. Nice job. Very good. Thank you. Okay. Now, let me call the next student. Okay. Yeah, you can relax now. And I'm going to call the next student. I'm going to give remote control to Ling Lu. Okay. Now I'm going to draw the straight line. All right, Ling Lu, it's your turn. Yeah, you can go ahead, draw on the screen for the tangent on the top and the cotangent on the bottom.
Okay.
Okay, yeah. You want to, yes, very good. I'm going to, hold on, okay? I'm going to draw the asymptote. Yeah, I'm going to draw the asymptote. Let's put the 2 purple asymptote there. And I'm going to, there. All right. I want you to go ahead and mark the position. So negative pi over 2, 0, and the pi over 2 for the tangent. Good. There you go. Very good. Okay, yeah. And then on the bottom, you can do the cotangent, please.
Okay.
Very good. Yeah, this is beautiful. Yeah, you just want to make the line go there. Yeah. Okay. We can use the eraser. Okay.
Okay.
Erase this part. Yeah, it's not easy to draw. Okay. Yeah, using the mouse. All right. So everybody, you can click the annotation button, and then you will have the menus. You can click the save. You will be able to save the screen as a big picture in your folder. Okay. All right. Next, Ling Lu, I want you also draw the secant and the cosecant. Okay. Let me.
Okay.
Yeah. Now you can go ahead. Let me draw the line for you first. So on the left, I want you to draw the secant. And on the right, I want to draw the cosecant. Just 1 second. This is SEC. This is CSC. Okay.
Okay.
Right. Can go. Remember, SEC is 1 over cosine. This guy is 1 over sine. So basically, you want to draw cosine first, and then you will be able to draw the secant, right?
Yes.
Go ahead, give it a try.
I don't know how to like draw the asymptotes in a different color.
So there you can click this, and then there you go. You can do this, okay?
Oh, okay.
There. Sorry, I didn't draw nice enough. There, okay? Yeah, can you mark the asymptote, please?
Oh,
Or let me change the line
okay.
style. There you go. You can mark it now.
That should be where's the
You see? Sorry. Yeah, you can undo. You can click undo. Okay. Okay, I fix it.
okay, thank you.
Okay. So look, let's look at here, okay? Because this is 0. This is your 0 position. And this is your 2 pi position, right? This is 2 pi position. And the midline, between here, this guy is 2 pi. So this guy is pi, correct? That's a pi position. Yeah, yeah, the way we draw here is not very clear. This is 2 pi. This is 1/2 pi, correct? Because cosine 1/2 pi is 0. That's why they have an asymptote. So this next asymptote is going to be 3 over 2 times pi. Yes?
Yes.
Now you can draw the cosecant by drawing sine x first. There you go. That's right. Very good. Nice. That's 2 pi. That's very good. Right. Yeah, you can take a rest now. Yeah, this is beautiful. This is good enough. So everybody, since we already learned the sine, cosine, okay, you are supposed to be able to draw the graph. You know the sine starting from 0, 0, cosine starting from 0, 1. Okay, yeah. Here our x is using the radian. How do we convert from degree to radian? We times that pi, we divide it by 180 degree. Okay, so 360 is 2 pi, and 180 is pi, and 90 degree is pi over 2. Okay, this is the top one is sine, the bottom one is cosine. The period for cosine is 2 pi. The period for sine, cosine are both for 2 pi, and then it's going to be tangent and cotangent. Tangent and cotangent both has a period of pi. Okay. Next, we also learned about secant x. If we want to draw secant x, we want to draw cosine first. If we draw the cosine first, we will be able to draw the sine easily. Okay. And next is cosecant. If we want to draw cosecant, we can draw sine first. We can easily draw the sine first. And then we are going to be able to find the asymptote. Any locations that your sine x equals 0, you draw the vertical asymptote. Okay, you draw the vertical asymptote. And then you can use this as your asymptote. But you know, at this location, one reciprocal is still 1. -1 reciprocal is -1. So you can use this as an asymptote. You can connect just like what Ling Lu did. Okay, very good. Our next question, we need to draw e to the power x. Okay, I didn't teach e to the power x. You learned that thing in your algebra 1 or maybe algebra 2. So let's draw e to the power x and draw ln x, which means the natural log, which is log e x. Who is e? Is a scientific number. Okay. Now I'm going to draw the lines. So then you can go ahead and draw this using the mouse. So then go ahead. Yes. Yeah, there you go. I change your color. You can use a purple color to draw on the left for the e to the power x. Go ahead, please. So then Yes, okay, I make it a little bit smooth, okay? Yeah, change a little bit, okay, yeah. When you want to show this to your teacher, you want to draw your line like that, okay? Next, you can draw a linear X. Go ahead, please. On the right, you can draw the linear X. So then continue. Can you go ahead and draw the linear X on the right? Draw your linear X. The linear X should be like this, right? No, you cannot hear me. Your e to the power x and the linear X is symmetric over y equals to x. So that graph should look like this, okay? That's our e to the power x and the linear X. So by the time now, all the students should be very good at drawing those functions. Okay. Next is going to be the piecewise function. Look at the piecewise function, or y equals this. This, in the domain, it is split into 3 different parts, okay? So at different x value, the graph will look different. Let's take a look. How do we draw question 12? Okay, let's see. How do we draw question 12? Look at this. Michelle, unmute yourself. Let's do number 12 together.
Okay.
Okay. -1. X will be less than or equal than -1. So when we draw this, we cannot draw this -1 all over. We have to stop at x equals to -1, correct?
Mhm.
Okay, so this is -1. Stop over here. And then tell me, what does this mean?
The like absolute value of the x has to be less than 1.
So x will be between who?
-1 and 0.
Hold on. At the time of learning absolute inequality, this is saying this. Does this make sense?
Oh, right. Okay, yeah.
Okay, so what does this mean? This means between -1 and the +1. Okay, yeah. If
Yeah.
I have equal, then you have equal here. Okay.
Mhm.
3x plus 2. 3x plus 2. That means who is the y-intercept?
+2.
We say 0,2. Okay, yeah. 0,2 is the y-intercept. Who is the slope?
3.
So this guy rise over the wrong is a 3. Yes.
Mhm.
Rise 3 over the wrong 1. So passing here. So your slope is this. You draw a line here. Yes.
Yeah.
Okay. And last one. 7 minus 2x. 7 minus 2x means you start from x equals to 1. You have the y-intercept of 7. And you have the slope of a -2. So you are going down by 2, wrong by 1. So you are going down. Okay.
Mhm.
That's what is this piecewise function. Piecewise function. Does this has asymptote? No, this one does not. This is a simple constant function. This is a simple linear one, a positive slope. This is a negative slope. Okay. Yeah. What's okay, if you want to draw this graph using the decimal, if you don't put this curly brackets, your x, y equals -1 is going to throw everywhere. So if you want to draw the graph in decimals, you put the curly brackets to limit your x. Okay. What's the purpose of learning those kind of piecewise function? The structure for pre-calculus. Okay, here I want to introduce this. Okay. So the structure for pre-calculus, as your school already start your pre-calculus, they first go through those old friend domain and range. Yeah, they first go through those domain and range stuff for, I believe, for most of the school. And then they are going to review everything you learned, like those exponential stuff, logarithms, okay? Yeah, decays, those things that you learned in Algebra 2 honor class or Algebra 2 pre-AP. Well, in log, in those log and exponentials, there are some hard questions. They do have some complicated questions like this, like that. Okay, yeah, so you need to be very familiar with those foundations. And okay, yeah, you need to do many complicated stuff, all those log and exponentials. And then your school will teach you those that's so-called optimization questions. Okay, for example, those fences, they told you all of them plus together is 200 feet. You know this 3y plus 2x equals 200 feet. And then what's the xy value when you want to reach this two area to be the maximum? If you want this area to be the maximum, what will be your dimension? Yeah, that's called optimization question. Oh, they say this is a semicircle. You have a point on the circle, and then you want to draw a rectangle, and you want to say in which x and y value you are able to make this rectangle the size maximum. Okay, so what we did, we read the restriction by doing some simple work like this, and then we express the area. For example, this area is x times y. In this equation, you will be solved the y equals to 200 minus 2x divided by 3. And then you do x times this whole package. Well, this is a quadratic function. Using quadratic function, you can do completing the square to find your maximum, no problem. But for this one, the question will become a little bit harder. So you will use, okay, this guy, y is this, and then this is the 2x. So 2x times square root of this will be your expression for your area. And then you can go ahead, use calculator to solve this guy's maximum value. And you find the maximum value, you will find out at what location of x you will reach to this guy's max. Okay, that's for pre-calculus optimization question. Next year, when you learn calculus AB or calculus BC, you will use the derivative way. You will do the derivative. Use those derivative, okay, to find out those values. That's what you are going to learn next year. Those things are really hard. After finish optimization question, the school will spend time for those kind of piecewise function. They give you really complicated stuff and they ask you to draw. Look at this, and this looks ugly. And then those kind of things. That's what's going to be covered for your school, pre-calculus, pre-AP. Okay, they might also go through those polynomials, including those long divisions, okay? Like those old friend that you did in algebra 2, do those long divisions, okay? Do those long divisions. This is examples from Dulles Academy. They do have some hard questions. Look at this, one question takes so long. That's those long divisions for the polynomial part. Of course, they also include those synthetic division, which you have learned in algebra 2. Some of them are very hard. Rationals. So you can see, okay, how do we draw this? Drawing this is not easy. I tell you, this is not easy. Number one, you need to expand this. Expand this is not too hard. You do x minus 2. This is x squared minus 9. And you come to this polynomial. You can use synthetic divisions, or you can do the long divisions. This guy divided by this guy is going to have, okay, so we can do something quickly over here. If you still remember the long divisions. X cubed minus 2x squared minus 9x plus 18. You put x squared. This guy minus this guy, which is plus. So this is 2x squared. And then minus 9x. And then you do x times 2x. There you make it to be 2x squared minus 8x. And then this is negative x plus 18. And then you have minus 1. This is minus x. And then plus 4. This gives you a positive 14. So fx get changed to x squared plus 2x minus 7 or minus 1 plus 14 over x minus 4. Who is this guy? This guy is the parabolic asymptote. This guy is a parabolic asymptote. Why? Because x squared plus 2x minus 1 equals x, parenthesis x plus 1 squared minus 2. The vertex is at -1, -2. This is the vertex -1, -2. So you got a parabolic asymptote. X minus 4 couldn't equal 0. So x equals to 4 is the vertical asymptote. So you draw this vertical asymptote. And then you will tell the x equals to 2, x equals to 3, x equals -3. That's your zeros. So you will pass here, pass here, pass here, okay? You will follow this trend of the parabolic asymptote. You will going down, you will be able to find your y-intercept by plugging x equals to 0. Y equals to -2 times 3 times -3 over -4. So this equals to negative of 9 over 2. So this is negative 4.5. The y-intercept is -1, -2, -3, -4, -4.5. You pass this 0. You follow this parabolic asymptote. You're going down, you touch here. You are pulled up by another 0. And then you will pull down by another 0. And then you follow this asymptote trend. Okay? You know, drawing those things are not easy. During Algebra 2, it is already hard. During pre-calculus, pre-AP, your teacher may give you even harder question to torture the students. Okay? Any question for this number 8? No question? No question for number 8? Okay. So all this topic is supposed to be learned before your school teach you the trigonometry. And then after finish all those parts, your school will do the trigonometry, which we have already did 12 classes so far in the summer. When your school finish all the trigonometry part, they will teach you the post-trigonometry. So for the post-trigonometries, you will do those kind of polar system, okay? We used to do X, Y system. And then in pre-calculus, we will learn the polar system. In the polar system, you don't have X, Y anymore. But you have theta and R, okay? Yeah, theta and R, yeah. By given your angle and your radius, you need to draw those kind of rose petals, okay? Yeah, rose petals, which is hard for this part. Yeah, polar system. You will see some really complicated stuff that you haven't seen in Algebra 2. And then the reason I want to talk about this is because next year you will do calculus. So calculus, first chapter will talk about the limit. They always give you those piecewise function to ask you the limit calculation. They will ask you when x approach to -1, what is your limit? And you see, this guy approach from the left, this guy go to -1. And this guy approach from the right, it also go to -1, okay? Let's see, number 12, numbers 13. Let's draw the number 13. Okay. Tina. Let's see number 13. So given this piecewise function, okay, if x is positive, we draw on this side. What is the vertex for this function?
0, 1. Wait.
Very good. Yes. 0,1. Very good. There. When x equals to 1, y is how much?
2.
Very good. when x equals to 2.
5.
There you go. There, okay. And then we can use smooth lines to connect them. Okay. All right. All right. Okay, that's a parabola. Okay. Now on the left, this boundary is x is bigger than 0 on the left. So we have to be careful. We need to make this guy to be open circle. Okay. Yeah. We need to, when you draw this, believe or not, sometimes your teacher is really mean. If you put an open circle, if you put a solid circle rather than an open circle, she may take off half your points. Okay, so you do here. And then we want to draw this. Who is this guy's y-intercept?
0, 2.
0, 2. So there, yes? Okay. And what's the slope?
The slope would be -2.
Okay. So this guy is there, yes? Let me draw straight lines. Okay. Does this make sense?
Yes.
Okay, that's how we draw this, okay? This point is not connected with this point, so we call this graph not continuous, okay? Yeah, let's keep in mind about those kind of hard definitions, yeah. Next year we will learn calculus, which talks about continuous discontinuity a lot. So we introduce the concept here. Your graph can be drawn here, and then I have to lift up my pen to finish my drawing. This kind of graph is called discontinuous. This is called discontinuous. Okay, discontinuous. All right. Believe or not, if you see the calculus first semester, first quiz, first test, the lowest score is just like 9 points. The average is failing grade. Okay. So we want to keep in mind about those concepts. Number 13. Next, we will look our old friends come. Okay. We want to draw those kind of, this is called rational function. Rational function. Let's see here. I'm going to show, first let's do this. Your first test in calculus is going to be drawing those graphs by hand without using calculator, okay? All right, let's draw here. Okay, number 14. Aiden. Who is the asymptote?
14, okay. So the asymptote is at x equals to 1.
Can you say it? Can you double check? It has how many asymptotes?
Has 2.
So
the vertical one is at x is equal to. Oh, you want me to say the horizontal one?
yes.
So the rule is that if the numerator, if the degree of the numerator is less than the denominator, it's then it's y equals to 0.
Very good. That's
So,
good.
yeah. And then vertical is x equals.
Beautiful. Very good. I'm happy that you remember the things I teach too. All right. This guy is x equals to 1, right?
Right.
Y equals to 0. There you go, correct? Okay. Let's give a few points so that we are able to draw. Look. X equals 2, Y equals
1.
there, correct?
Right.
Okay. And x equals to 3.
1/2.
X equals to 1.5.
It's 2.
There you go. So we have another 2 points. One is here, one is here, correct?
Right.
Okay. All right. Now we can draw. Yes.
Yes.
Let's draw. They also have the other side, right?
Right.
Yeah. Go ahead. Give me a few points on the left.
So if x is 0, y is -1. And then when x is equal to -1, y is -1/2. And then when x is equal to -1, wait, no, when x is equal to -1/2, y is equal to negative, wait, hold on. When x is equal to 1/2, y is equal to -2. Yeah, when x is 1/2, y is -2.
There. Yes. Okay.
Okay.
All right. So let's summarize the way to draw those kind of rational graph. Number 1, find your asymptote. Yes.
Yes.
Okay. The vertical asymptote is easy to get. Make your denominator equal 0. You get your vertical asymptote. The horizontal asymptote, I did teach this to everyone before. Y equals to, look, a x to the power n plus b x to the power n minus 1 plus c times x to the power n minus 2 plus da 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 over x to the power m minus 1 m minus 2 plus da da da. Okay. Tell me the rules. Scenario 1, n is less than m. What happened?
Then, okay, so n is less than y is equal to 0.
Horizontal asymptote, y equals to 0, correct?
Right.
Number 2, n equals to m. Horizontal asymptote,
Would it be
y equals,
would it be y equals to, would it be y equals to 1?
hold on. When n and m equal, yeah, all those things can be ignored because this guy is the highest order. Yes, you don't need to worry about those things. Okay, yeah. And then y equals to a divided by a1. Correct? Yeah, it is equals to 1. If and this will be equals to 1 when these two equal. Okay, yeah. Correct.
Right.
scenario 3, n is bigger than m. What do you say?
Is it? I mean, we
You
have
want
an-
to, you do long division, right?
right.
Correct? Remember the example I showed you just now. The parabolic asymptote is because n is m plus 2. N minus m is 2. That's why you have a parabolic asymptote. If n minus m equals to 1, you
That's
have
a
the slant asymptote, correct?
Right.
Makes sense, okay? All right. Now that's how we draw this one. Very good. Next student. Brian. Okay. Aiden already listed the way to draw the asymptote. Can you tell me? I give you the blanks and you tell me what should I put over there.
Y equals 0 for the
Y equals
horizontal.
0. Very good. That's beautiful. This order is lower than this order. There's even no x term. This is x to the power 0. Of course, 0 is less than 2. So y equals 0. That's beautiful.
And
Next.
x equals -2.
Yes. Very good. Next, we draw it, okay? This guy, right? Correct?
Yes.
There, okay? Let's give a few points. Say x equals to 3, y equals, and no, we don't need to give so big. Yeah, we just make it near to -2. Okay, say x equals 0, y equals
0.25. Wait, no. Wait, yeah, sorry, 0.25.
That's good. And x equals to -1.
Y equals 1.
Very good. Let's draw the point. This is the first point. -1 is going to be +1. Yes. And then you see, it's going to be like that, right?
Yes.
This asymptote is to help you draw the trend, okay? So we connect them. This guy is going to follow this horizontal asymptote. Then going to that direction is going to follow this vertical asymptote, okay? All right. Let's draw on the left. Say x equals to -3.
Y equals 1.
There you go. When x equals to -4.
0.25.
Yes, that's beautiful. You made it. Good job. There and there. Yes.
Yes.
And then you draw the lines like that. Okay. Okay. Does this make sense?
Yes.
Okay. And I did teach this to students before. If you don't remember, it's okay. This is the time for you to pick up. Eden. Eden, look at this, okay?
Okay.
This is x -1 to the power of 1, right?
Yeah.
Okay, look. 1 is odd, yes? 1 is odd, correct?
Yes, correct.
Because 1 is odd. So this is the asymptote. And they switch from positive infinity to negative infinity, correct?
Correct.
Right. This is 2.
Mhm.
2 is even. 2 is even. So they stay on the same side.
Right.
Makes sense?
Makes sense.
Yeah, stay on the same side. This is a switch. Negative infinity to positive infinity, or positive to negative infinity. This guy stay on the same side, either both positive infinity or both negative infinity. Okay, if this order is 2. If this order is 2 or 4 or 6 or 8. Okay, if this is 1 or 3 or 5 or 7. Okay, this rule always apply. Okay, that's the thing I teach you over here. Look, for those lower, very low grade in pre-calculus, pre-P class, you have to watch out for several topics like synthetic division, rational graphing, logarithms, those and optimizations. That's those places you want to watch out, because that's those places. Question will be hard, test will be tough, students get very low grade, okay? Number 50. Number 16. Okay, let's draw this one. Okay, I already draw here. I'm going to just explain the question, okay? So, Aiden, look at this.
Okay.
For this graph, who will be my vertical asymptote?
X equals to 2 and x equals to -2.
Good. That's a 2 vertical asymptote. Who is the horizontal asymptote?
It's the same. So it's y equals to 2.
Yes, because this guy over this guy is 2, so y equals 2. You made it. Okay, when you have the asymptote. And then you can make x equals to 3 or 4, and then x equals to 1 or 0. And you get those points, and then you can use those asymptote as your trend. You are able to draw here. Yes?
Yes.
Okay. And let's watch out here. We talk about the even and odd. The denominator is x plus 2 to the power 1, x minus 2 to the power 1. So if you find out that here is negative infinity, your next point is going to be jump to positive infinity, because this is to the power 1. It's odd. You switch, correct?
Right.
And then you give x equals -1. You find out your y value, and then you are able to draw. This gives you positive infinity. And because this is a 1, so this guy jumped to the negative infinity. Okay?
Okay.
That makes sense?
Makes sense.
Okay, so this is number 16. Look at number 17. Yeah, everybody. Go ahead. Do the long divisions. Do the long divisions. And then tell me what you find out. Do the long division for this. Okay. I want everybody to do the long division to find out the slant asymptote. Tina,
Yes.
this guy, after doing the long division, what you find out?
I haven't gotten it yet. Could you give me
Okay.
some time?
Sure. Okay.
Would it be x minus 1 with the remainder?
Yes. Plus.
Plus 3 over x minus 1?
Very good. That's it. Yeah. Okay. So this will be called as a, Tina, go ahead. What's this name?
Linear function?
Slant asymptote.
Oh.
Okay.
Uh-huh.
Look, hold on, okay, over here. This polynomial over this, when n is smaller than m, which means this denominator has higher order. So if your x go to infinity, this ratio will be 0, all right? When this n and m are the same order, okay? You can just say, oh, your horizontal asymptote is a ratio. Is this two-number ratio, correct? But when n is bigger than m, this is the time you do long division to find out your slant asymptote. If n minus m equals to 1, you find out your slant asymptote. Okay? If n minus m equals to 2, it's going to be a parabolic asymptote. Make sense? Okay. If this is 3, you will have that kind of polynomial asymptote. Okay, yeah, but they won't give you so tough questions. Most time, just 1 or up to 2. Okay. All right. So we come back to this question. You know, when you draw this, as long as you find out your asymptote, yeah, this is your vertical asymptote, your slant asymptote. When you see this two asymptote is there, you will easily see, hey, I know this is a butterfly, you know, this is a butterfly. On this side, the butterfly go here. This is x minus 1 to the power 1. This is odd. So switch from here down there. Make sense? Yeah, so you have this butterfly as a pair. Okay? Yeah. In your pre-calculus, your teacher will give question like this. And they say, hey, use the graph calculator, do the optimizations, find out your minimum point. So what you do? You use a graph calculator. There you go. Make sense? Look, if we draw y equals to x minus 1, this, yeah? As you can see, this graph exactly show this blue line is a beautiful asymptote, slant asymptote for our graph, correct? For pre-calculus, they will ask you, say, I want to find out my minimum point. See, this guy, yeah? That guy is your minimum point. Right now, we don't use the calculus way because we haven't done those hard stuff yet. We just use calculator to find out the minimum and the maximum, okay? These 2 points is called the local minimum and local maximum, okay? Yeah. Students, if you feel this class is too hard, there are so many concepts you never heard of before, I make YouTube videos, you check out the videos later, okay? Yeah, there are so many information in this class. So the way I show here is using calculus way to do it by hand, okay? Yeah, we are able to solve this by hand. And this is going to give the exactly same solutions as what we did by calculator. Okay, well, this is about rational graphing. Rational graphing will be utilized in the optimization part. So that's number 17. Okay. The last part we are talking about is doing inequality. Inequality. I have very good ways to solve the inequality very fast. I'm going to show you the tricks. Okay, look. This guy. Ling Lu. If I ask you solve this inequality, what's the way you solve this one?
Oh, what you would do is you would factor it, and then you would put those individual factors in the equation. So like x squared minus x minus 12 factors to x plus 3 and x minus 4. And then you would put that greater than equal to 0. And then you would solve. So 3 is,
okay, let me show what I did, okay? That has 2 zeros or x-intercepts. This is position of -3. This is position of 4, correct? This parabola opening up because 1 is bigger than 0, correct? So what we do? This is saying you have a parabola like that, correct? So we are looking for positive. Which part give us positive? There, there, correct? Okay. So the solution is x is bigger than 4 or x is less than -3. Make sense? This put in the interval notation. There you go. Correct? Okay. So I'm going to ask you to look at number 19.
Okay.
So I'm going to erase my work here. Now, have you draw the line? when I first draw the x-axis, I will mark my roots from left to right.
Mm-hmm.
Which one you want to mark first?
X plus 1 cubed.
So this is -1, right?
Mm-hmm.
Next,
And then x minus 2 squared.
so the 3 roots is 2, -1, 5, correct?
Mm-hmm.
There you go, right?
Mm-hmm.
Okay. And then this is less than or equal than 0. What's the highest order? 2 plus 3 plus 1. The highest order is
6.
6 is even, right?
Yes.
Look, if we have the highest order as an even number, if the leading coefficient is positive, our graph will look like that, okay?
Mm-hmm.
Does that make sense?
Yes.
So we do from the left, and our graph will go like that. It's going to pass, look here, okay? Watch out. Let me see this one more time. If the order here is odd, if it's 1, this is called a cross. If it's 1, it's going to be cross. If it's 3, it's called a V goes through. If it's even, it's called a bounce. Okay.
Mm-hmm.
Now, let's see. Here is the V goes through. What does V goes through mean? It is because this guy is 3. 3 is way more bigger than 1. Okay. So when x is approach to here, it's going to be dragged very flat over here. That's called V goes through. When it come to 2, x minus 2 squared, you bounced, okay? You bounced back.
Mm-hmm.
And then at 5, you cross. That's what this graph looks like. Does this make sense?
Yes.
So you have here, V goes through. And then here you got bounced. And then this guy you cross. Okay?
Mm-hmm.
Students, you may feel curious, say, teacher, are you sure your graph is correct without using calculator? Yes, I guarantee my way is working, okay? If you master the skill I teach you, you will do all those different inequality very fast and perfect answer. Okay, yes. Yeah. When the teacher grade your stuff, they are checking if your trends is same. Yeah, you see these two guys have the same trend. Okay. Yeah, you see the shape. Yes. You're going from up down here. You have those kind of vehicles through, and then you are pulled up by here, and then you are going to go down, but you pulled back. That's what it is. Exactly same as the graph calculator. Now we have the basic trend now. We are looking for less than or equal than 0, correct?
Mm-hmm.
So because equal, that means those points can be included, right?
Uh-huh.
So when we finally choose our answers, we will choose there, there, and then there. Okay?
Mhm.
And then make sure we say, hey, those points we are allowed to choose because we have the equal sign here. Okay? This is my way of doing those inequality. Well, your school may ask you to do the sign chart. Here is how to do the sign chart. Okay. I explain here the way to do the sign chart, okay? When you do the sign chart, you first mark this. You mark negative infinity on the very left. Then you mark your lowest roots. Here is -1. And then 2. And then 5. And then positive infinity. Okay? After you mark those, what you do next, you are going to look at this. Okay. You are going to carry on the factors who has the lowest factor, who has the lowest roots. X plus 1 has the lowest roots of -1. That's why you put this on the very top. X minus 2, x equals 2 is the second one. So you put the roots here. You put this order not because of 3, 2, 1. No, you put this order because x equals -1. You put this. You put this x minus 2 here is because 2 is on the second position. You put a 5, x minus 5 is because 5 is on the last position. You put this order. Look at here. When x is bigger than 5, when x is between 5 and infinity, positive, 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 of course. This is positive. Your product is positive. When x is less than 5, bigger than 2, this guy is, say here, x plus 1. When x is between 2 and 5, it is positive. Positive. X minus 2 square, of course, always positive. X minus 5, because you are on the left, of 5, so you put negative over here. Okay. And the positive, positive, negative gives you a negative. Okay. That makes sense?
Yes.
Okay. And then between -1 and 2. Between -1 and 2. X plus 1 is still positive. X minus 2, you are between -1 and 2. So, but you have a square, so you still have positive. X minus 5, you are less than 2. Of course, you are less than 5. So this is negative. Your product is negative. When x is between -infinity to -1, well, you are less than -1. So this guy is negative. Negative, positive, negative. So that product is positive. Okay. And then you have this. Plus, 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 product is plus. Plus, plus, negative, your product is negative. Plus, plus, minus, your product is negative. This 3 product is positive. So you are looking for this product negative. this. There you go. Because it has an equal sign, so you include this. That's your answer. Does this make sense? Yes. Okay. Any questions so far? Any questions so far? Students, you may have question for this. What will happen if you have a fraction like this? How do you do this kind of fraction? You know, those fraction graph is really, really complicated. You don't want to spend a lot of time drawing this to just for the inequality purpose. So I have a trick for 21. A copy down question here. You want this to be bigger than or equal than 0. Well, this is cube. If I times another x plus 2, this becomes 2 to the power 4. Of course, somebody to the power 4 is always bigger than 0 or equal than 0. This is asking for bigger than or equal than 0. Denominator couldn't be 0. So you can make x not equals to -2 excluded. And then you can draw this graph. How do we draw this graph? Easy. -2.5, -2, +1. So you go in 1 plus 2 plus 1 is 4. It's an even number. So there you will pull down by this. This is crossing point. And then you will pull up by this -2. Come at location of 1. This has order of 2. And bounce point, bounce up. You want this to be bigger than or equal than 0. Oh, there is okay. There is okay. Numerator can be equal to 0. So everything here is okay. But denominator cannot be equal to 0. So -2 excluded. X is bigger than -2. X is less than or equal than -2.5. Because this guy equals 0, this equals 0. Totally fine. Okay. Well, if you want to use a sign chart, you are very welcome to go ahead and use it. Okay. That's for today's class. So we quickly go through all those questions for this up to here. We will continue moving on to those trigonometry questions in next week class. Next week will be the last class for pre-calculus. Okay. Yeah, I'm going to upload the videos and you can leave now. Thank you. See you next week.